Ladies and gentlemen, this is the sixth lecture in the module of Lean Six Sigma, Measure Phase. During the lecture, the following topics will be covered: process capability, Sigma level. Process capability is used to compare the actual variation in a process, which we can call voice of the process, to its allowed variation limits, which we call voice of the customer. The proportion of current values that fall inside specification limits tells us whether the process is capable of meeting customer expectations or not. The specification limit is equal to customer requirements. For the first histogram, the process is fully capable of meeting requirements. But, for the second histogram, process is only partially capable of meeting requirements. Process capability compares the output of an in-control process to the specification limits by using capability indices. The comparison is made by forming the ratio of the spread between the process specifications to the spread of the process values, as measured by 6 process standard deviation units. The CP and CPK are two indices used to measure process capabilities, as follows. The process capability is equal to USL minus LSL divided by 6 sigma. The process capability index is equal to the minimum of either USL minus mu divided by 3 sigma, or mu minus LSL divided by 3 sigma. If process capability is less than 1, then the variability of the process is greater than the size of the specification range. Typical goals for process capability are greater than 1.33 or 1.67 for critical mission and safety items. When the process is centered within the limits, then CP is equal to CPK. A capable process must have CP and CPK at least equal to 1. However, Six Sigma quality requires that CP to be equal to 2. When CP is equal to 0.5 and CPK is equal to 0.5, then the process is out of limits, but it is centered. When CP is equal to 3 and CPK is equal to 3, we can say that the process is within limits and it is centered. So, if the CP and CPK values are the same, the average is centrally located. The larger the values of CP and CPK, the more close to CTQs. When CP is equal to 1 and also CPK is equal to 1, then the process is exactly within limits and centered. When CP is equal to 1 but CPK is equal to 0.4, the process is still exactly within limits, although process is not centered. If the CP and CPK values are different, the average is not centrally located. The larger the difference in the values, the more offset the overall average. The only correct situation for the car parking is when the car is centered and within the limit. As the situation in the middle, when CP and CPK is equal and larger than 1. It is important to remember the following. CP measures how close a process is running to its specification limits. CPK measures how close to target and how consistent around average performance. A process with upper and lower specification limits are 23.22 millimeters and 22.89 millimeters respectively. Process mean and standard deviation are 23 and 4.2. calculate the process capability, CP, and the capability index, CPK. USL is equal to 23.22, LSL is equal to 22.89, mu is equal to 23, and sigma is equal to 4.2. By calculation, CP is equal to 0.013. Please note that CP is less than 1. Conclusion: the process is off limit, but is it centered? To answer this question, we have to calculate CPK. By calculation, we found that CPK is equal to 0.0087. CPK is not equal to CP, so process is not centered. A process with upper and lower specification limits are 23.22 mm and 22.89 mm respectively. Process mean is 23, and standard deviation have been reduced to 0.02. Calculate the process capability, CP, and the capability index, CPK. USL is equal to 23.22, LSL is equal to 22.89, mu is equal to 23, and sigma is equal to 0.02. By calculation, CP is equal to 2.75. Please note that CP is greater than 1. Conclusion: the process is within limit. Since CP is greater than 2, it is more than 6 sigma quality. But is it centered? To answer this question, we have to calculate CPK. By calculation, we found that CPK is equal to 1.83. CPK is not equal to CP, so process is not centered. For unilateral and bilateral capability, we have 4 cases. Process capability for two-sided limits either does not take into account where the process is centered, or does take into account where the process is centered. The equation is different between the 2 cases. These 2 situations are shown in first and last equations. Also, process capability can be in the upper specification limit only, or in the lower specification limit only. These 2 situations are shown in the second and third equations. PP is the process performance. A simple and straightforward indicator of process performance. And PPK is the process performance index. Adjustment of PP for the effect of non-centered distribution. PPK, usually calculated from a sample standard deviation, S. CPK, usually calculated from a population standard deviation, sigma. Process Performance Index basically tries to verify if the sample from the process is capable to meet customer CTQ's requirements. It differs from process capability in that process performance only applies to a specific batch of material. Samples from the batch may need to be quite large to be representative of the variation in the batch. An example of this is for a short-term production run. Process performance generally uses sample sigma in its calculation. Process capability uses the process sigma value. Because CP and CPK use estimated sigma, and PP and PPK use actual sigma, they have different uses. CP and CPK can be used to measure a system's potential capabilities, while PP and PPK measure the system's actual performance. To access the process capability analysis in Sigma XL, click Sigma XL, then click Measure, then Process Capability, then click Histograms and Process Capability. Or click Sigma XL, then Graphical Tools, then click Histograms and Process Capability. Select Data, and then click Numeric Data Variable, Y. Enter USL and LSL. Check normal curve as shown. Click OK. Resulting histogram and process capability report is shown. Or, to access the process capability template, click Sigma XL, then Measure Templates and Calculators, then click Process Capability. The template gives the following example. Notes for use of the Process Capability Indices calculator. This calculator assumes that the mean and standard deviation are computed from data that are normally distributed. Reports CP, CPK, if entered S is within or short term, using a control chart. Reports PP, PPK, if entered S is overall or long term. Steps to conduct process capability analysis in Minitab. Go to Start menu, move to Quality Tools, and then to Capability Analysis. From the drop-down menu, select Normal or Non-Normal Analysis, based on whether your distribution is normal or non-normal. Choose the data column, lower specification limit, and upper specification limit. Once we click OK, Minitab generates the process capability in a separate window. Consider the process expressed by the 100 data observations below. Let the USL and LSL to be 55 and 13, respectively. Calculate the process capabilities indices, CP, CPK. Please pause the lecture and solve the exercise. Results show that CP, CPK, PP and PPK is less than 1, then the variability of the process is greater than the size of the specification range. Please perform the first activity and send your outputs by email for assessment. Please perform the second activity and send your outputs by email for assessment. To calculate the sigma level metrics, the following terms will be used. DPU is the defects per unit product. DPU is equal to the number of products divided by total number of units produced. Number of opportunity is equal to the number of product. DPMO is the defects per million opportunities, which is equal to DPU times 1 million. For example, if 650 parts are produced and 20 parts are defective, then DPMO is equal to 20 divided by 650 times 1 million, which is equal to 30,769. To access the process sigma level of the discrete data calculator, click Sigma XL, then Measure Templates and Calculators, then click Process Sigma Level, Discrete. Or, click Sigma XL, then Measure Templates and Calculators, then click Process Sigma Level, Continuous, to access the Process Sigma Level, Continuous Calculator. The template gives the following example for discrete data. Notes for use of the process sigma calculator for discrete data. Total number of defects should include defects made and later fixed. Sample size should be large enough to observe 5 defects. The template gives the following example for continuous data. Note that This calculator assumes that the mean and standard deviation are computed from data that are normally distributed. The content of liquid detergent bottles is being analyzed. 12 bottles, randomly selected from the process, are measured, and the results are as follows. In fluid ounces, in the same process, suppose the value of the USL of the bottle is 16.05 fluid ounce. What is the process yield and quality level? Please pause the lecture and solve the exercise. The process mu is 16.029 and sigma is 0.02, while x is equal to 16.05. Then, by calculating z, which is equal to x, minus mu, divided by sigma, which is equal to 1.04, from z table, at z is equal to 1.04, the area left to z is equal to 0.8508. The shaded area is equal to 1 minus 0.085, which is equal to 0.1492. Then dPMO is equal to 149,200, which result in sigma level between 1 and 2. The yield of a steel rolling process has mean of 100 tons per day and standard deviation of 15 tons per day. On Friday's shift, the yield of the process reached the record of 145 tons per day. The shift's manager claims that he is adopting Six Sigma tools, which caused that record. How you would analyze his claim? Please pause the lecture and solve the exercise. The process mu is 100 and sigma is 15, while x is equal to 145. Then by calculating z, which is equal to x minus mu divided by sigma, which is equal to 3, from z table, at z equal to 13, the area left to z is equal to 0.9987. The shaded area is equal to 1 minus 0.9987, which is equal to 0.00135. Then dPMO is equal to 1,350, which result in sigma level is 4.5. Calculate the sigma level for each of the following cases, shown in table. Please pause the lecture and solve the exercise. Using the sigma level template, short-term sigma level and long-term sigma level can be calculated. Please check in the table the solution for the exercise and compare it to your solution. Please perform the activities and send your outputs by email for assessment. Please download from the resources the instructional video for process capability and sigma level calculations using Excel templates, Sigma XL, and Minitab. Measure phase Sigma XL.mp4, process capability Minitab.mp4, measure phase templates.mp4. Thank you, and see you in the next lecture of the measure phase.